Welcome back, and today we're in our last unit of our last lesson of the first unit, solving for a variable. And the main thing we got to do here is all we're doing is getting a variable by itself. So these problems are going to look different than a normal algebra problem, but we still use the same inverse operations as we did in the problems we've been doing. But again, at this point, instead of isolating a variable and getting a number answer, you're going to isolate one variable and have the other variable on the other side of the equal sign. Now, the problem's going to tell you which variable you're solving for. So this guy, we're solving for x. What does that mean? It means we need to get the x term by itself. So what I like to do is I like to put a box around my x variable term, and my goal is to get the box by itself, okay? And this, again, this part right here, it tells us what to isolate because we got two variables. Well, which one are we moving? Well, the problem's going to tell you. It tells us which variable to isolate. And the first thing we're going to do is move the other variable, okay? And we're going to use inverse operations. So opposite of plus 8y is going to be, opposite of minus 8y is plus 8y. We do that to both sides. And this is here going to be unique. We know these guys cancel. And we just have 11x on the left side now. This part over here is tricky because you have a number and you have a variable. You cannot combine these terms. Okay, guys, because one's a number and one's a variable. They are, in fact, unlike terms. So we need to be careful of that. So what ends up happening is, and what I like to do, so we can't combine here. And we need to put the variable term first. Or I prefer to put the variable term first. So what we do, we take this 8y and we swing it to the front. And we take this 32 and we swing it to the back. So we just have 8y plus 32. The reason for this, excuse me, is we're setting up for slope-intercept form. If you've seen slope-intercept form before, you might say, oh, okay, we're getting ready to solve equations. If you haven't seen that before, that's okay. Just trust me. These problems work easiest if you have the variable term first right here in the future. So we have moved the variable to the other side. And our second move, is we want to isolate our specific variable now, the x. And we're going to do that just using our classic, inverse operations. So we're going to divide everything by 11. Now, I say everything by 11. So we divide each of these guys by 11. And usually that's what we do. So usually it's going to be dividing every term by the value before the variable. We can add that to our notes if we want. Usually by dividing every term by value before the variable. And so what we have over here, our 11s cancel, so we just have x. We cannot really work with this part right here, 11 or 8 over 11. We can't really work with that. So that's just going to be 8 over 11x. We kind of write it as a fraction. And then 32 over 11. You can't get an integer with that either, and we really want to get integers if we're going to reduce our fractions. So we're just going to leave it an improper fraction 32 over 11. Yes, you could make it a mixed number, but trust me here, it's usually easiest in the future if we get used to working with improper fractions. So if we leave our numbers like that, we don't have to reduce them. We don't have to turn them into a decimal. Actually, scratch that. Reducing is a good thing when we can, but we definitely don't need it as a decimal. Anyway, and that's your answer. And you might say, whoa, oh, hold on, I messed up, guys. You know what I forgot? This is a y right there. Let me change that. Because 8y divided by 11 is, in fact, 8 11, or 8 elevenths times y. Boom, there you go. That looks better. So the answer will usually have fractions, though, and that's okay. The answer will often have fractions. That's okay. Yeah, it's not too bad. All right, let me do a couple more with you guys, but this is how to solve these problems right here for a variable. So I'll give you a couple more examples. And again, problems are going to look like this. Solve for x. The problems will always give you something that you're solving for. Otherwise, again, you won't really know what you are in fact solving for. 2x minus 7y equals 14. We're getting our x by itself, so we are going to put a box around the x term. Now we've got this minus 7y next to it, so opposite of minus 7y is plus 7y. What I do to one side of the equals sign, I need to do to the other. Now I have 2x on the left. I can't combine these guys, so remember variable swings to the front, and the number swings to the back. From here, I want to get my x by itself, so I divide everything by 2. And we have x by itself. 7 over 2x, or 7 over 2 times y. I cannot combine those guys. Or I'm sorry, that doesn't give me a integer, so I just leave it as a fraction. 7 over 2 times y. And then 14 over 2. I can reduce that. That's just a 7. 14 divided by 2 is 7. So we're going to write plus 7. And bop. There we go. Let me do one more with you. And again, if I go too fast, you can just pause the video, rewind, whatever you need to do. Next one, I got a little trickier one. 8. We're still solving for x. 8x plus y equals negative 8. All right. Process is the same. Put a box around your variable term you're solving for, and move the other variable. We're going to minus y from both sides. Remember, we cannot combine the 8 and the y. So we've still got our 8x on the left. Swing the y to the front and the number to the back. Make sure we just keep the signs with the numbers. We need to do that. From here, I need to remember there's an invisible 1 before that y. Why do I need to do that? I'm going to divide everything by 8 to get my x totally by itself. And I want to turn this guy right here into a fraction. And my fraction is that part right there. So I have my x. So this is negative 1 over 8y. And then 8 over 8 is just 1 minus 1. We have to make sure we keep our signs correct. And there we go. So, hope that helps. And thanks for watching, and have a great day.